All right, Janesh, all yours.
Great, thanks, Imrit, for organizing this, arranging, as well as inviting. I'm Dinesh. I'm on the technology evangelism team at Amazon, kind of focused on furthering the awareness of AWS. So just a quick show of hands, how many people are currently using Amazon Web Services in production? Okay. How many people are aware of Amazon Web Services? Okay, cool, good. So, in this talk, first of all, I feel and I think Seattle area's this particular logo is like the best logo. It not only resembles the Seattle aspects, but also Java and other things. So I really like, and I wanted to just bring that up. But anyways, so I'm going to talk about how to really build web applications, Java web applications in AWS, and kind of go from there and understand and give you patterns and best practices on building some of those in the AWS cloud itself. I spend most of my time building architecture. So if you Google my name or just Google cloud architectures, you will be able to find a few white papers that I've written based on these basic patterns and anti-patterns about Java itself. So let's make this really interactive. This is a small group. Feel free to ask and raise questions. If I'm going too fast, and stop me. As well as, I don't want your undivided attention. Get your phone out and tweet and take pictures and put whatever you like. So feel free to kind of talk about as well among your friends as well. So I'm going to talk about briefly, quickly talk about Amazon Web Services platform. I assume everybody knows the benefits of the cloud. Not having to pay for upfront investment, pay as you go, not having to manage the hardware, the infrastructure, getting to the market very quickly, because you have the resources at your disposal, and most importantly, that you have everything is an API, so you are using services and so forth. I'm not going to focus more on the benefits of the cloud, because you will see that I know how you can actually go about building it. So I'm going to quickly talk about the Amazon Web Services platform, some of the recent developments in the next 5 or 7 minutes, and then I'm going to tell you a love story, which is going to be fun, and it's really cool. How you build a small application and then gradually we take advantage of the cloud in order to actually build a highly scalable, highly distributed, globally deployed web application. So without any further ado, let's get started. So most of you might already know Amazon.com. Amazon.com is offering a variety of different infrastructure for all businesses and all sizes. So in this case, we have what we call geographic regions. Regions are essentially rings of data centers that are deployed across around the world. We have 5 regions today in US East, US West, Europe, Singapore, and Japan. And each region has availability zones. Availability zones are logical data centers that don't share the same powering, cooling, flood panels, fault lines. So they treat them as fault-tolerant zones. So you can build high availability applications. I'm going to talk about that in detail. Apart from that, there is edge locations, which are essentially POP servers for your content delivery network. We have 18 edge locations around the world that basically edge cache your static content. So we are growing and adding more and more POP servers around the world as well. So on the top of that infrastructure, there are a variety of different infrastructure building blocks. Some people like to say infrastructure as a service and so forth, but these are essentially what the building block services are, and I've categorized them into these main buckets: compute, storage, network, database. Most of you might already know about Amazon EC2. How many people don't know about EC2? Oh, few. So let me give you a quick, in the whole process you will learn a little bit more about EC2 as well. But so EC2 stands for Elastic Compute Cloud. It gives you virtualized server capacity by the hour. You can put your own operating system on the top of that, or you can take advantage. We offer a variety of different operating systems from Windows, any version, any distribution of Linux, Open Solaris, and so forth. And you use what we call Amazon Machine Image, which is a pre-compressed, freezed file system. So you say, I want 5 of these using this Amazon Machine Image, and it will clone your infrastructure, start up those instances, which are essentially virtualized servers, and you pay by the hour. Just like any other utility, you pay compute by the hour. Auto scaling, let me stay there. I'll talk about a little bit more detail into that. On the storage side, we have Amazon S3, which is a simple storage service. Simple storage services, as simple as you can get. You give us blob of data, we'll take that blob of data, store multiple redundant copies of data in multiple geographically distributed data centers. You take the blob, you retrieve the blob of data using the key that you have provided. You encrypt the data, you can store the encrypted blob, and you download it, you can decrypt it back. There are different styles of storage models, different variety of different redundancy models available, lots of features like versioning and other things. From a computer science perspective, I feel this is a distributed data store, a highly redundant distributed data store. Amazon EBS stands for Amazon Elastic Block Store, which is a block device that you can mount onto an EC2 instance. So you have persistence as well as your compute going back together. Amazon VPC on the network side stands for Virtual Private Cloud, which is a network isolation that will help you bridge between your existing data center and that of the cloud. So you can have your same IP address range, your 10.IP address range in your corporate network, and map that into the cloud so that you can have best of both the worlds. VPC is much more powerful mechanism to build hybrid applications, hybrid clouds, and environment. So you can kind of do best of both the worlds. And not only create, have multiple VPCs spanning across multiple availability zones, but also actually have multiple VPN connections connected to that particular VPC. So you have different branch offices connected to that environment. I will talk about briefly the latest service that we released called AWS Direct Connect. So now that you can actually connect to your data center, your existing corporate network can be connected to the data center to that of the cloud, you can also invest and get dedicated connectivity. I'm sorry, I didn't see your hand up.
That's fine.
Yeah.
For all that connectivity, do you guarantee some sort of a bandwidth available?
That's where this Direct Connect is coming, and thank you for that question. Please ask questions, this is good conversation. So, So we released this product called AWS Direct Connect, which is essentially a direct connectivity, a dedicated connectivity to one of our regions. And if you have, let's say, a connectivity through an Equinix data center or other data centers that we provide as an authorized provider, then we provide a dedicated connectivity, a 10 gig Ethernet connected to each from that Equinix data center to that of to one of our regions. So if you either have already in your servers and routers in that data center, or you have to just get one router and actually it will give you a dedicated connectivity between the regions. So you get lower latency to connect your data.
How about without the direct connect for, let's say, S3 service or the messaging?
Without the data connect, what is the latency?
No, what's the available bandwidth? Do you limit that somehow?
It depends upon your connectivity to the network itself. It depends upon how much, which region you are connecting to, which closer, whether it's connecting to US West or US East, whether you're connecting to Singapore endpoints and so forth.
But you don't provide any sorts of a guarantees.
Guarantees for bandwidth, because it is related to any.
Because a while back I was testing Amazon S3 and EC2, and what I saw is that my connection was very good, but looks like somewhere in Amazon it was limited to 300 kilobytes per second. I don't know if it's a per IP
Let,
or
let me
something.
let me tell you the story and let me walk you through some of those things, and then if you have those questions around latency, we'll talk about more detail. So let me just quickly show you how this whole thing sort of works, because this is very important for those who have not used EC2. So once you quickly launch an EC2, once you sign up for EC2, you will log into or what we call the management console. Management console looks something like this. This is your Elastic data center dashboard. You can see you have some instances running. You have some. I talk about all of these today, but this is your way in which you will manage your virtual infrastructure, right? So you click on launch instance button. You will see multiple Amazon machine images, which I mentioned. Think of this as an ISO deployed in the cloud, so you can quickly clone your entire infrastructure. You don't have to do your installation and configuration, which is the time that I spend most of my time in when I do Java applications. So you can clone your entire infrastructure. You can have somebody else create your image or use an existing image, and then take advantage of that, so you increase your developer productivity.
Where that said your instance will launch in the US East, is that just an example? Your slide before this showed that your instance will start in the US East?
Yeah, correct. So you can select your US East region.
Okay.
That region means it is connecting to the US East endpoint,
Yes.
and it will launch and put all your data, your computer, whatever you want in that region.
So something that we're starting by launching in this region, we can
Correct.
specify this region?
Yes, you have to specify which region you want to start your instance. In fact, you have to also specify which availability zone you want your instance in, and I will talk about some of that later.
Okay.
But I wanted to quickly give you a run through of how this whole thing kind of works together, right? So you have Amazon machine images. There are more than 3,000 different Amazon machine images of different permutations and combinations of operating systems and technology stacks, so you can take advantage of that. These are a quick start wizard that will help you kind of walk through whether you want a 32-bit version or 64-bit version and so forth. Question?
Can we try this out for free, or do we have to?
Yeah. Let me talk about that as well. It's all free for up to a certain amount, a certain tier, and then it's pay as you go as you see. I will talk about that. There are different types of EC2 instances depending upon your configuration. There are CPU cores, memory. You decide which instance type you want to select, and then go backwards and understand whether your application is good. And there are different ways in which you can start these EC2 instances as well. So once you start, you will see these instances. This is very similar to the Amazon machine images screen, where you see these are my instances that are currently running. Each instance comes with a DNS, an IP address, which you can log in through PuTTY, or if it's a Windows terminal, you can simply log in through remote desktop. So you can simply log in with your favorite terminal. So what I wanted to kind of quickly go through is how EC2 really works, how you can get started. It's free to get started, and you can quickly launch an EC2 instance and then kind of test it out and see whether it works for your application. So let me go back. So there is Amazon VPC, which I thought, yes, sir.
Just one quick question. So the available images for the various virtual machines, is Amazon in any way policing those, looking for malicious images? Because last time I looked, it was just the whole public is, I say, I build one, and I say, oh, it's public.
Yeah.
And, so it's like, I don't really trust a lot of people.
Correct, and I agree, and it's a valid, it's a valid concern, and it's a little bit of art and a little bit of science here. No, we do have specialized controls in which we will manage and understand which, when you create an Amazon machine image, we run certain scripts on our side to see whether they are embedding their malicious code or whatever, as well as it is more about community aspects as well. So there are images by Oracle, Microsoft, and others, the high solution providers which are authentic, valid, and a way. There are customers like Ubuntu images maintained by one of our best community members, Eric Hammond on holistic.com, so you can go and manage, and he actually talks about what he does and how he actually builds those Amazon machine image, what are the contents of this Amazon machine image in each image that he has built. So those it's more about community involvement. We are working on a variety of different ways in which we can add reviews and ratings so that you can see which images are really useful and being used by lots of other customers as well. So if you go to AWS and Amazon.com/AMIs, you will see a complete community management with the ratings and stars, and if you have a higher star, you can assume that it is a good Amazon
So
machine.
use images from well-known sources is the solution at the moment, is it?
Yeah, from a trusted source, from a well-known source, from a person who is keeping it up to date, all of those, and that these are good best practices.
Or build your own.
Or build your own, yeah. So let me just walk through again. VPC, as I mentioned, is the network isolation layer. You can create multiple VPN connections to your network. I will talk about that if you have more information, if you need more information. Elastic Load Balancer is a service, essentially a load balancer, software-based load balancing, it is fault tolerant and also that sits on front of your web servers, so you can scale your applications more horizontally. Amazon Route 53 is our authoritative DNS service. Any guesses why it's called Route 53? Yeah, port number 53. So DNS, it's a way by which you can programmatically manage your DNS records and the hosted zones. Amazon, on the database side, Amazon RDS is our relational database service, which is MySQL managed offering as well as Oracle managed. So with just one click, you can I want to move this database from 2-core box to a 4-core box. I want to add 100 gigabytes of storage with one click. All of that happening through APIs, so you can actually provision your infrastructure and your databases. It does most of your database administration tasks like patching, patch management, and so forth. So you can actually focus more on the things that you do the best, rather than focusing on database administration and make migration tasks and so forth. Question?
Does the database still qualify under the free program?
Database doesn't qualify on the free tier program yet, but we are working on it. And if you are interested, please let me know what part and which database you want. Yeah.
So this leads into the question. My point is that last time I looked, the Amazon SimpleDB, which does qualify, you don't have an offline development mode for.
Okay, so let me first talk about what SimpleDB is, and then come back to your question. SimpleDB, it does qualify for the free tier program. SimpleDB is our key value, highly distributed, redundant data store. So you have key value stores. Anything that you put in is indexed, so you can query. You don't have to manage the database. It's not relational in nature. There are no joins that you have to worry about. Or if you have joins, go back to relational databases. Or in general, focus on it's horizontally scalable. So you have multiple databases that you can manage from that perspective. SimpleDB. The question here was, can I manage that on premise, right? Or an API, a sandbox environment?
I want to develop against it without actually having to deploy.
That's a good suggestion. I don't know. There are APIs and SDKs that you'll be able to use, but yes, it uses the service and uses the systems. Using the services is actually making a call to service. But there is a significant amount of free tier on SimpleDB, so you will be able to take advantage of that. But if you think that we need sort of a sandbox environment which is just free for certain usage, that's something that we can absolutely consider.
I mean, if you're developing on the road.
Yeah, if you
Correct,
disconnect.
I agree, It's a good feedback.
So if I'm a little guy just playing with some website I want to develop, I would have to install my own database on my own image until
Stay-
such
Hold on to that question, I will answer all that question as soon as I go into that love
into
story.
the migration path thing.
Yeah, yeah. Yes, sir.
So I remember you mentioned that you can add like 100 gigs to your database server. Those 100 gigs, is it some kind of storage, or should it be S3, or can it be also?
No, that's EBS, which is mountable EBS storage. That's what RDS uses behind the scenes to actually add more storage for your database.
And can you also like, say in case I'm done with it, I want to take it back?
Yeah, absolutely. That's the beauty about the cloud. You only pay for what you use. You can take out your data and you stop paying for it, stop paying for the infrastructure as well as it's using simple MySQL. It's nothing but MySQL, right? So you can use MySQL dump utilities, your migration utilities, all the tooling that is there with MySQL will work directly as is with RDS as well. Elasticache is one of our newest service that we released 2 months ago. It's a distributed in-memory cache. It's nothing but memcache D. So you can actually have a caching layer built between your web servers and your app servers and your database servers. On the higher level building blocks, there are a variety of different services to do more specific tasks. For example, if like mentioned, a lot of people mentioned about Hadoop. How many people are Hadoop users? Okay, cool. So Hadoop is my favorite service as well. Amazon Elastic MapReduce is a hosted Hadoop stack on top of EC2 and S3. So with just a few clicks, you can actually get a complete optimized Hadoop stack. You run your jobs and you crunch all your data, and it will shut down your infrastructure when the job is done, or if you want to keep it running, you can keep it running as well. You have Hive, you have Pig, you have Cascading, all the different Hadoop frameworks or the community tools that are built around it, also available on Hadoop, on Elastic MapReduce. Likewise, there is content delivery network, there is messaging, we have SNS, which is a simple notification service. So it's essentially nothing but a publisher-subscriber model. You publish some messages to a topic. Your topic is actually getting sent to multiple subscribers that are subscribed to that particular, either it's email, either it's HTTP, or you want to put something into a queue. So that brings to SQS, which is a simple queue service, which a producer-consumer pattern. You have lots of producers, you want to buffer those messages, and you have lots of consumers. So you want to build a highly distributed, loosely coupled application using the queuing system. Likewise, we have a simple email service. There are 2,000 emails per day that you can send. It's a bulk email transaction service. So you can easily, essentially it has just one function that you have to call called send mail. And you can integrate that into your application. We have done lots of investment on this layer, what we call the cross-service infrastructure or cross-service features. Lots of customers, were, especially on the enterprise side, required multiple user accounts within a single account. So I want to have Bob, who is a developer, only access to terminating EC2 instances or starting EC2 instances, but not terminating EC2 instances, while I want Alice an access to this part of the S3 bucket and so forth. So you can give granular permissions and controls using the AWS identity and access management, which is this particular service. As well as we just announced a federation, so you can connect back to your LDAP repositories as well as Active Directory repositories to buy temporary tokens, issuing temporary tokens for your users. You can either create a user, and everything is an API. You create your users programmatically as well through an API. If you want to monitor any of these resources, for example, CPU utilization of your EC2 instance or your memory of your EC2 instance, you can use Amazon CloudWatch, which is our monitoring service. You can create thresholds and alarms. So if it goes above a certain limit, you want to take some action, No, those are all built into Amazon CloudWatch. I will talk about in a little bit more detail about Elastic Beanstalk. How many people know about Elastic Beanstalk? Okay, few. Elastic Beanstalk is essentially a management and a deployment service that will instantiate all the necessary infrastructure that you need to launch a Java application. So this is an excellent way if you don't want to worry about managing infrastructure, but or servers or hardware. All you worry about is uploading your WAR file to the service. The service will, behind the scenes, create the necessary infrastructure, your load balancer, your instances, and so forth, and it will scale as well. So you can use Elastic Beanstalk for most of your Java applications. Today it's actually a container service. Today we have Tomcat 6 and Tomcat 7 containers. We are going to add more types of containers as well. So you can do more effective, you can think of this as a platform as a service offering where you just worry about your uploading your WAR file. CloudFormation is one of my, yes sir?
I'm sorry, when I was reading about the Elastic Beanstalk myself and my partner, parent partner, one of the questions was, the database configuration stuff seemed to be using system properties, yet there didn't seem to be very good documentation on what all you could specify to the system properties.
Oh, that's a really good feedback. Yes, there are certain, actually I can point to some of the documentation which is there. Please send me an email. Databases don't scale horizontally as the web server scales, so we have to make sure that how you actually configure some of your systems in a best practices fashion. And I will talk about some of those in the story that I talk. But please send me an email. I have my information, and I will send you my card as well.
Janesh, I have a question also.
Yeah.
So you talk about APIs for all these different services to be able to programmatically provision them and things like that.
Mhm.
Is there like a standard set of technologies or languages that you expose these APIs in?
That's a great segue to my fourth layer. So good question. So how do you access these services? But before I go there, I wanted to talk about CloudFormation, which is one of my favorite services right now. I'm working on that. Essentially, with a single JSON template, you can provision all the infrastructure resources from it. It's a provisioning service. So you mentioned how many EC2 instances you want, what is the configuration setting, what are the security settings, what are the different ways in which you want to have load balancer set up. All that you mention in that deployment descriptor or template, and it will provision that infrastructure for you. So you can actually use, it's essentially infrastructure as code. Your code to provision infrastructure can be put into a source control repository as well. So it's a way by which you can manage your infrastructure, and all these infrastructure is essentially just using the API endpoints and creating the infrastructure for you. So there are different ways in which you can access this API, these APIs. All these services that I talked about have an API endpoint. All of these services are inherently scalable, or they give you an option to scale horizontally or adding more capacity, as well as all these services are pay as you go. You only pay for what you use. You don't have to worry about your infrastructure. It's all services in the cloud. Right? So there are different ways in which you access the command line interfaces. There are Visual Studio toolkits as well as Eclipse toolkit. You can live in Eclipse and get all the information, all your resources, what's the thing that you see and saw just now in the web console. You can do all that in an Eclipse plugin, as well as there are almost all SDKs available from Ruby to Java to PHP to Python and others available on our website as well. So this is the complete infrastructure, our services, what I like to say a buffet of what Amazon Web Services is providing. You don't have to use all the services. If you don't want, you can only pick the services that you like. You can use the services in any combination you like, and and the beauty is you can use any programming paradigm as well as any operating system that you like on EC2 as well. So any questions about the platform? This is just a complete full overview of AWS as a service. Yes?
How do you handle versioning? So these services, as they evolve over time, what's the user base going to have to do?
Every single service has, for example, currently, let's say I pick S3. S3 exposes 4 simple functions: get, update, delete, and get, put, update, and delete. So these are the simple functions. Every single has a version tag attached, so they're all backwards compatible. If you're using an older version of the service, you just keep on using the endpoints.
What is Amazon's position though on ever retiring a service?
Retiring a service.
Or a service call? I mean, you could say that, yeah, everything's gonna be backward compatible. Reality is, at some point in time in the future, something is gonna have to not be.
It depends upon the usage. You want more and more better services. For example, we launched versioning capabilities for S3, which you put your object and you can actually do versioning on that object. That's a new feature on the Web Services API. If you want to use that service, you continue using the newer endpoints, which is the tags that come with it. And there are services that are currently there which related to there is a sunset policy also associated with each of these services and stuff. Question at the back.
Is there any way we can set like a predefined limits on usage, that something like, okay, I don't want it to ask about this usage, so end of the month I don't get surprised on my credit card or something?
Correct, yes, yeah. So every single service has connection to CloudWatch. You can set your threshold on that service and it will notify you based on some of the usage. Currently, we don't have a billing CloudWatch. So if it goes above $20, I want to get notified, or if you want to know what you would like to do. You want us to shut down your EC2 instances, which is not a good idea, obviously.
Like something it reaches 80% of threshold, then notify me.
Correct. And that's what we're currently working on, a billing side of things. But right now, you can do from a usage perspective that if your usage is on certain level, then you want to get notified through an email.
What storage or database integration is there for Elastic MapReduce?
Storage or database. So Elastic MapReduce uses EC2 and S3 as the data store, but as Hadoop stack comes in, it will be running in HDFS. So your HDFS is your cluster, which will be using that distributed file system is being used by all the mappers and reducers.
And we will be responsible for moving something from Amazon storage to HDFS?
To S3.
Okay.
So you send it to S3, and then you'll create what we call a job step. The job step will be essentially first step would be just to take the S3 data, put it in SDFS, and then you run all your mappers, and each of the mappers is going to access SDFS.
Okay, and then write back data.
And then once it is computed, you store back your data on S3 back. Yes, sir.
For the libraries and SDKs, is there some plan or for how much this is being done by Amazon as opposed to when we integrated with S3, we integrated with some guy who'd written the Java in S3.
That used to be the case 2 years ago.
Okay, yeah.
Now Amazon has published and maintains all these SDKs. So we learned a lot from our customers that lots of different third-party tools are available. Now all these SDKs are available, managed by Amazon in a single drop file. So there is a jar file that you can simply take, and it will have all the services SDKs, APIs available.
I think most of us lost the conversation there on all the acronyms. He uploaded to S3, started his MapReduce, which was able to access S3, and then he wrote it to where?
Okay, great. I have a slide on Hadoop and
SDFS is what on that?
It's a Hadoop distributed file system, and it's a distributed file system that is used by the Hadoop cluster.
And it really writes back to S3. And
correct. It's a job step that you have to say, I want to access my data from HDFS, run my mappers, and then put my output data back into S3.
So there-
I will talk about that a little bit detail as a cloud.
Sorry, I don't remember all the acronyms related to Hadoop in particular while looking at
Yeah,
your picture
yeah,
there. So.
and there are so many of them, like Hive and Pig and Cascading and all those.
Yeah.
But anyway, this is what the services is. No, I highly encourage you to take advantage of these services. No, just play with it. The best value proposition that cloud provides is that it's easy to get started, and it will cost you a Starbucks latte to just spin up an EC2 instance, test it out, and then shut it down. So you don't really have to worry about it. Question?
Okay, so if I want to run a Hadoop, do you guarantee the minimum read speed from the S3?
Minimum read speed. So it depends. Yes, there is certain benchmarks that you can have. There are certain optimizations you can do, like TCP window scaling, which will you can multi-thread your request through S3 as well when you are downloading your request. The best part is there is no data transfer cost between EC2 and S3.
Yeah, I understand.
But there is
I
no
need a Hadoop for big data, so
Okay.
I'd like to estimate how
how
long
much.
that,
Yeah.
how long that will run.
Correct.
So for that,
We
I
don't
need a
publish-
minimum read speed guarantee.
Yeah, we don't provide any sort of guarantees because it's at the end the network is a shared system. So I would encourage just to kind of see test it out and see what read speeds you are getting, and that will
But
be your benchmark.
If there is no guarantees, then
There is no
next
guarantee of.
time it might be crawl like a turtle.
Well,
So the test will tell me nothing about the future performance.
correct, yeah. And I encourage you to run the benchmark tests in different times of the day, different times of the week itself, and see which one what you get. Kind of average it out and see what is the chance. in that. Yeah.
The past performance is guaranteed.
To comment on that, our experience for EBS in particular, that's a very real concern. And you can get a factor 50 reduction in throughput, and it'll just suddenly, it just goes that. So it's very hard to design a database layer where you can run a 50th of the speed you were running at a minute ago, run for an hour, that's and then come back again, right? Because it's because someone else is just hammering that same disk, right? And the guarantees are.
So there are customers today who would do RAID 0 and have 4 volumes and kind of stripe data across multiple volumes to get throughput that they need. So that is one more strategy that lots of customers could use for their more database related workloads. But for Hadoop and others, you have to kind of do a little bit more testing around it because Hadoop is not using EBS. Hadoop is using Hadoop distributed file system.
Since you have access to this data, why not publish typical responses so people can look at it historically?
There are lots and lots of people have already published their own benchmarks online, which on our forums, on the web. But Amazon doesn't publish any of the benchmarks because every benchmark is really different. Every sysprep, every tool is different, so it depends upon what services. So let's hold on to the questions. These are good questions. Let me go to the story and this will answer lots of your questions as well, right? So anyway, the most important thing I wanted to kind of highlight that it's not just about the services, but it's more about the ecosystem behind it. Today you can run Microsoft Windows Server software, SharePoint, Exchange, and other servers applications on AWS. You can run any Oracle suite of products from Oracle 11g, whether you want it by the hour or you want it by bringing your own license. You can run Oracle Fusion middleware as well as eBusiness Suite as well as your 11g soft database. And there are a variety of different third-party tools and services that you can take advantage of with the ecosystem that's powered by the cloud. Just wanted to kind of bring that up. So now let me talk about, yes?
You go back, you have a right scale.
Yeah.
But according to the stack, it looks like you are trying to put them out of business.
No, Lightscale is actually one of our premier partners.
Yeah, but they historically provide those management tools your infrastructure used to run, but now with the Foundry.
Rightscale is one of our premier partners. They get almost all of our private beta announcements so that they can integrate better with their platform. They are also innovating up the value chain, and they have to as we innovate, they are keeping up to that stack. And I think they are doing a fabulous job, and they continue to be our excellent partner. So let me talk about the story. The story is about scalability. I'm going to talk about about how you can build a web application with a powerful web application in Java. So this story is about Andy. Once upon a time, not so very long ago, there's a boy named Andy. Andy was around 25 years old, and typically the people in the age of 25, they have a problem. He was having a grave problem, according to him, that he was not able to find a Friday night date. Right? Every Thursday, he's actually very frustrated about the fact that he doesn't have a Friday night date. But Andy was a member of Seattle Java Users Group, and he was very smart.
Program his way out of that problem.
There are lots of senior people around and Andy was aware of the cloud and other things. So he went on and he got an idea, and he thought, necessity is the mother of invention. Let me actually build something what he calls Thursday.com. Okay, Thursday.com is not an ordinary dating website. It's a dating website in the cloud, right? The beauty about Thursday.com is that it takes advantage of all the cloud on-demand aspects. Right? So in the beauty about and the coolness factor of Thursday.com is that it will go live at 3 p.m. on a Thursday, and then all the people will log in, put their profile information, people will find their Friday night date, they'll confirm it, and it will shut down at 7 p.m. thereby creating a Black Friday effect. Right, to that. Lots of people will log in to that particular environment. People will they'll upload their video, they'll chat, they'll find their Friday night date, and the entire website will be shut down. And every Thursday this gets repeated. So every time it's going to be fresh, new information, new people logging in. So it's a great way to get more and more people. Is it a cool idea?
Yeah.
Good. Yeah.
Well,
So
what I really love is
Can't find a date and fire up Amazon mechanical chick.
what's that?
I like that.
What would be really cool is to get a cloud girlfriend, that you can control an API and
Yeah. Hopefully in future. Right. So he's building this in the cloud. There are two problems and how actually cloud will actually help them. First, the website is coming up online, going live at 3 p.m. and shutting off at 7 p.m. There is no infrastructure running the rest of the week, so it's much more cost effective for him. So this doesn't happen in so-called private clouds or so-called your own hardware infrastructure. You stop paying for it when you're not using it, right? So he is just paying for that 3-hour time frame, a 4-hour time frame. And secondly, cloud is because there will be lots and lots of people logging in during that period of 4-hour time frame. He has to make sure that the website scales. He doesn't get 404s. He is making sure that every single customer that logs in has a user experience, a better user experience, and the scalability that so he has to make sure that the application also scales dynamically. So,
Well, he has a third problem.
yeah.
The third problem is he only works in one time zone.
One time zone.
Yeah.
Well, let me talk to that. I'm going to actually come to that. That you will not date a girl from South America or maybe
It's
in
the same
Asia.
time zone.
So this is a mock-up of the website. You can see it's magically elastic dating every Thursday of the month of the week. Now it's currently sleeping. It will have a countdown. People will log in. Now they will have a game. You can log in. You add your profile information, and then you find your Thursday night date. Right? So far so good. So he decides to build this cool idea, implement this idea for it, he starts very small. So within one availability zone, he spins up an EC2 instance that I just showed you earlier. Now you can log into a simple EC2 instance, log in a way so that you can SSH directly to that box, and he installs Apache. You get complete root level access to that instance. So you are able to log into that and install whatever tools you want. In his case, he starts with Apache, Tomcat, he installs MySQL, he makes sure, because it's an EC2 instance, because it's MySQL, he wants to take periodic backups to Amazon S3, which is more redundant data store. So in case the EC2 instance is terminated or he wants to shut it off, his data and his backup, the data is still available. So far so good. He creates what we call an elastic IP. Elastic IP is a static IP address that maps, that is remappable. So as soon as your new EC2 instance comes up, it comes with a DNS. You can, if he terminates and starts a new EC2 instance, his static IP can be remapped to this new EC2 instance. Question?
So the Amazon S3 bucket that he's got there, when does he pay for that use? I mean, when the system's not down the rest of the week, I mean, not up the rest of the week, is he paying for that storage?
If he deletes that storage, he's not paying for it, but he's not paying for, he does pay for the storage one. Okay. S3, there are three parameters for pricing. You pay for the storage, you pay for the data transfer that's going out, and you pay for the request charge, right? Anything that you put inside the cloud is free, so there is no data transfer in cost. And data transfer out is tiered, and there is an online calculator that can help you estimate some of the costs.
So he does have some constant
if he
overhead.
keeps the data.
Yeah.
If he keeps the
You
data.
better get a date.
If he doesn't, he'll not have to pay for that data or backups, right? But he's keeping data. As a good best practice, you're taking backups on a redundant data store, right? So far so good. He launches a simple website with one single EC2 instance, and he's able to kind of go public, right? He talked to his friend. His traffic got doubled 100% because he's now accessing. His friend is also accessing the website. So this comes to my. So this comes to my. I'm going to talk about different patterns and the ways in which you can architect for scale. So this comes to my first pattern. He went to our talks. He has listened to lots of our getting started docs and our white papers and so forth. The first pattern that comes is design for failure and nothing will fail. But essentially it means that if you are pessimistic about your design, and if you have built with the pessimism in there, you will end up building a better design overall. So in this scenario, if you assume that hardware will fail, you assume that software will fail, you assume network outages will happen, you assume that connectivity will not be there, and based on that, you end up building a better design because you have built your processes and practices in place ahead of time when the actual outage actually happens. So in this scenario, when he wanted to make sure that anything fails, he actually starts, like let's say the EC2 instance actually failed, how he can recover some of that data, either from the backups or from EBS volumes. So here, what he does is, instead of just storing all the ephemeral data onto an EC2 instance, which is your I/O, or your every EC2 instance comes with hard storage space. We call it ephemeral storage. We advise not to use that because it will go away if you terminate your EC2 instance. So in this scenario, he's using what we call Amazon EBS volumes. He spins up to EC2 instance volumes, he mounts that onto an EC2 instance, and it just acts as any other file system. So you can make sure that your MySQL binary logs in your data logs are actually going onto an EC2 instance, EBS volume. So far so good. If the EC2 instance dies, he can quickly bring up another one. That volume will still be there, and he will remount that volume back in. So building with this design principle, design for failure, and that actually is going to be there in everything what we do in the entire storyline. Also, designed for failure, nothing to fail. So now he sees that there is value that a lot of people might log in, right? He started talking about, Andy started talking about his application to a few of his friends, and he started that, okay, what are the minimal things that he can do to just make sure that he can do edge caching. So here in this case, second pattern comes to keep your data much more closer to the customer, right? So there are lots of log files, lots of videos, lots of audio that might get uploaded, lots of images that are there in this particular server. What he does is essentially moves the static content onto CloudFront. CloudFront is a CDN. It has direct connectivity to S3. So your edge caches is, your content is edge cached in 18 edge locations around the world. It is much more closer to the customer and it's much more faster because it is accessed very quickly. So he distributes his static workload from the dynamic workloads. He puts all the logs and static data also on S3. When customers upload their audio, video, they directly upload to S3 rather than uploading through the web server, and thereby he's reducing the workload, the server workload even less. Question?
So of course he's got SSL running to his EC2 for
He's running what?
SSL.
Correct, yeah.
And so his static data is also SSL then?
You can by default it's not. But if you are serving your traffic from here, it will be SSL. But if you are serving off from here, you have to have your HTTPS endpoints that you have to use SSL from there. Right? HTTPS endpoints for S3. So every object that you send to S3, you get object URL addressability. So if your object name is my object, you are uploading to a thing called a bucket called my bucket. Your URL is going to be s3.amazonaws.com/mybucket/myobject. That's your URL. You have complete control over your access and complete ACL access control list, so you can specify whether you want data to be public or you want data to be private and so forth. So your data has, or you can have HTTPS endpoints and HTTP points as well.
Is there an extra charge for the SSL endpoint?
No. But when I come to load balancers, that is another thing which I would highly recommend as a best practice. So far so good. So he starts talking about the services. He is now he thinks that this particular architecture is good, and he's talking about some of the application to his friends and his social network, and one of the colleges actually picked up, and they feel the website is very cool. You can log in, they can find their Friday night dates, and it's a good application to get. So he quickly realizes that what is the problem in this architecture? Tell me. How he can go to the next level of scaling?
Essentially, if he does that compute on a single instance, he has a problem, and probably his MySQL database.
MySQL database, yeah. So most often when you are building a good application, a good architected application, you want database is typically the bottleneck. So you want to take the database out of your web servers and kind of make for a single instance go to a 2-tier application. So that's what he does. Because he was running MySQL on his EC2 instance, he can use existing MySQL dump utilities and others to just simply take that data and then move it to Amazon RDS database instance. And it is, again, an API similar to what you saw in EC2 instance management console. You can create an RDS DB instance for that. So in this scenario, he doesn't have to take backups. Amazon RDS will do periodic backups based on the frequency that he sets. So it will do automatic backups to S3, and he doesn't need a DBA in this scenario because that is going to be managed by Amazon in this case. So far so good. He went from a one-tier design to a 2-tier design, kind of separating the EC2 instances and the database. Just a quick cloud tip, side tip. Now, the beauty about the cloud is the on-demand aspect. So when he's actually upgrading to newer software, he can actually do much more cooler things. One of the best practice that I see in some of our customers is using elastic IPs when you upgrade to newer versions. So typically in a scenario before the cloud, what we used to do is we bring up our staging servers. We have staging servers in place. We deploy our new code in there, and then we actually move to the production environment. And then there are different types of environments and so forth. Here you can actually use servers on demand. So in this scenario, when he wants to upgrade from a version 1.1 to 1.2, he quickly brings up another Amazon machine image. He has pre-configured Apache and Tomcat onto an EC2 instance. He adds the newer version of the software. He does all his tests, his JUnit tests. If all the tests are green, he actually makes the staging environment its production environment, and connects remaps the elastic IP address and terminates the old instance. Right? So this is a great way to actually do your upgrades in general. Typically, this is a design pattern called blue-green deployments, and this is one of the best ways in which you can do massive deployments, and you want to do continuous deployments and so forth. Even if there are thousands of EC2 instances in it. Amazon.com uses blue-green deployment methods to actually do newer versions as well. So this is just a cloud tip that you can use elastic IP remapping feature very quickly. So now he does more research. He said, like, what if I get tech crunched? I get slashed-dotted? What if at all, if there are customers that will come in, right now only one college is using it, and immediately there will be like lots of colleges using it. I need to be prepared for this storm that might come. So that comes to our third pattern, is implementing elasticity in your application. Now, elasticity is the fundamental property of the cloud, and most of its benefits are coming from, of the cloud benefits comes from elasticity. So how do you actually go about implementing elasticity in a kind of in a simple way? And then you can do a variety of different things there too. The first thing that he does is he builds an Amazon machine image out of his running instance, or he creates a new Amazon machine image together, and then he adds two things. A load balancer replaces the elastic IP from a load to a load balancer, and this cool group, what we call the auto scaling group. Auto scaling group is a service that you can use within AWS that will auto scale your horizontally for your application. So in an auto scaling service, you specify now what your CPU utilization is and what EC2 instance or image you want to provision, right? And if it meets and if it goes above that particular metric, it will automatically provision your EC2 instance and connect back to the load balancer. So in this scenario, he sets an auto scaling group. He sets if it goes 85, if the CPU utilization goes 85 and above, remember everything is an API. Everything is a service. There are no humans that you have to call that I need more servers, right? You are calling through services, right? So in this scenario, he did 85% CPU utilization. If it goes above that of this particular server, automatically start these Amazon machine image that I start, provision that into an EC2 instance, connect that to the load balancer, and send all the new requests to these newer services, newer EC2 instances. So it's horizontally scaling. Another feature of the auto scaling service is that it maintains the minimum set of or your fleet size. So if you have set it to let's say 1, and if this EC2 instance fails, it will automatically bring up that EC2 instance and run all your processes there. So it is sort of self-healing in that particular scenario as well. Question?
I was just wondering, does it scale itself back down too?
Yeah, correct. Yes. So it has a CPU utilization, upper threshold as well as a lower threshold. So if you say 20% and below and it stays there for 3 minutes, no, I want to shrink my resources. I want to terminate my EC2 instances that I started. So thereby I want to save on my cost as well. I don't want to run applications infrastructure when it is sitting when nobody is using it. So then this comes to this newer set of applications that can be built with the cloud, essentially what I call build websites that sleep at night. When nobody is using it, shrink your infrastructure and save on your cost. Question, sir?
So what do you do on startup to know that it actually is fully started up? I mean, every application has different things that it might be waiting for. You need to wait. How do you define that?
There are multiple ways you can say. There are multiple health checks that we do based on the EC2 instance and the ELB instance that are and the elastic load balancer. There are different ways in which you can say if this comes up, automatically call this new service and tell that this is my server configuration. I have come up. And you change the status as well, and you do essentially describe instances call and you say whether it's up, whether it's up. You do polling to find out whether it's up or not. Yes, sir.
So, does the elastic load balancer take stickiness into account?
Yes, and there is session stickiness, as well as coming back to my your older question as well. You have a way by which you can translate your SSL back to your EC2 instances as well. So your EC2 instances will continue to take advantage of your certificates that you have created on for. That's a feature that we just added a month ago. And it has session stickiness, so it will keep your session alive. Yeah.
Amazon's charging model will charge you for an hour if any fraction of an hour is used.
That is correct.
So is there some intelligence in scaling to say if I have an instance running, I might as well keep it until it's run for its hour?
That's a good question. I don't think there is, but you can actually monitor that this is my time that has come up. There is timestamps on each of the EC2 instances when you start, and once it is nearby that hour, you can actually terminate it later on. That's a good question, though. It's something that we might be probably offering in future, more easier way.
So is everything you're describing here work equally well for proprietary software like IIS and Windows and .NET?
Auto-scaling service will work with Windows instances as well. It's using network load balancer in this scenario. IIS is running in a different way. But yes, these are typically basic architecture design. It is working on CPU utilization. It is working on network utilization. It is working, let's say you want for Java, you want Java heap size and you want to scale horizontally based on that metric. There are different ways in which, in the case of IIS, you might have to do a different metric and auto scale on that parameter. So far so good. Now, let me skip this just in interest of time, but basically, he sends notifications, he puts all the catalog and configuration information, kind of taking load off his web server and app servers rather than and putting that off onto a simple DB, a database, and doing monitoring, doing simple email service, and now he can horizontally scale his web tier. That way he can serve more requests more effectively. So one of the best cloud tips that I have learned is loose coupling. And this is one of the design principles that Amazon implements in everything they do because of the distributed nature of things. So typically a tight coupling will be, there is a controller class, that's calling a function inside a controller B class, and they are tight coupled. So in this scenario, if this controller dies, the entire system is down. Right? If there are lots of requests to controller A and it's taking more time to process, everything is going to be slower. Right? So loose coupling can be done with queues in between. Right? Queues acts as buffers. Queues acts as their intermediary. So all the requests are going into queues, and this controller's responsibility is only that, take this message from the queue, process it, put message in another queue. right? So in this scenario, if this controller B dies, the entire system is not affected. The systems are just getting, it's still getting buffered. So when you bring back up that particular controller, you can resume your state by using queues in between, from reading back messages from the queue. So that's a great way to build loosely coupled applications by adding queues in between.
What if the queue dies?
Was that?
What if the queue dies?
So queue is currently in this scenario a simple queue service. It is distributed by design, so there are multiple redundant copies maintained for every queue. So that's a service instead of application.
So the user
That's
doesn't have to do
funny,
anything to get that.
Kind of a guarantee. So you will get message at least once, but maybe 10 times.
Because it's distributed in nature, right? Distributed in nature, it is redundant across multiple physical locations.
Where's the queue in this diagram?
In this one, there is no queue, but essentially
okay.
you are running a Tomcat server, you are having your application components, then you have a Java controller, when you have other controllers, you're designing queues in between of those. So your controller classes essentially is going to address the queues. Call a queue and delete a queue or add a message to the queue. But that was just a side tip on how loosely coupled applications are being built. So now, obviously, the question will come in, what about databases, correct? Like now I'm able to horizontally scale if there are lots of requests, but database is still the bottleneck, right? So now, he starts, that comes to our fourth pattern called leveraging multiple availability zones. And this is one of the best features of Amazon RDS. With a single click, you can tell Amazon RDS that start a synchronous standby node in another availability zone and do synchronous replication. In case this actually fails, it will automatically fail over to this the standby node. He's increasing the availability of his database, and if database dies, he actually can he'll automatically fail. And this is the power of using Amazon RDS. You can do that still in running MySQL on EC2, but this is doing it much more efficient manner and effective manner. Question?
And the availability zone to be in a different geographical region?
Currently, no. We cannot be in a different region itself. There are multiple availability zones within a single region. We don't do cross-region replication.
Yeah.
Because it will have all the geographic latency that might exist.
Yeah,
So if there's an earthquake in LA, and
To
LA
add-
basically shuts down, I'm screwed.
Hold on to this thought and I will come back to that. I'll come back to your question.
S3 is.
They're all in LA now.
Okay,
Well,
so
yeah.
give up on a single database image
This
concept.
is
Yeah.
great for redundancy, and this isn't great for scalability.
Scale. Hold on to that. Really cool question. So that brings to the scalability part as well. This is more about high availability, that you are moving to have multiple availability zone. In case this fails, I can immediately fail over to Amazon RDS will immediately fail over to the standby node. But what about scalability? Just like here you have isolated your static traffic from your dynamic traffic, you have put all your static images, audio, video files on CloudFront and its edge cache. You can do the same for your read and write traffic, thereby increasing scalability, right? In this scenario, with just one click again, you will be able to instantiate read replicas and have read traffic coming off from your read replicas. This happens with simple one click on the console, and this is what I really like. Why? Because this will be like asynchronous replication. All the read load will be coming off from this server. All the write loads will continue to go on these particular servers.
Behind the scenes, or is that under the covers, or is that something you have to program for?
It's an API call. You say, I want 5 read replicas. It will automatically set up asynchronous replication, and it will connect.
So no code change.
No code change required. But yes,
What
you
are we
will have
reading
to.
from there?
Is that?
Can you give explicit examples? We're not reading database. We're not doing database calls. We're reading what from there?
It's read data. You're reading data versus writing
This is
data.
MySQL, you're doing
It's just-
different, you just select.
Other database instances that are fixed data.
So are these different names that are put into,
What
how do I
do you
resolve
sorry,
these?
what-
Images, files, HTML, what is being read from these blue
The same
all
boxes
the
on the left?
relational data.
Relational
Database.
data.
It's
All
a
the
MySQL
relational data that you
select.
have in your application. All your static data is all in the S3 buckets and so
So
forth.
as you do commit, as your application does commits or transaction completes to the primary master, basically that data gets replicated.
Yeah, it will replicate the data using
Standby.
standard MySQL application technologies.
What's the data that resolves?
Your application.
There is a
Always
link.
on the static data.
Support standard MySQL
I'm still waiting for the example.
Yeah, application is using a connection string, right? Your connection string is what matters, right? So yes, your connection string is important. Right.
Okay, so 7 o'clock on Thursday rolls around and everybody who is going to get a date, wherever they may be, have gotten it. Now we're going to shut the thing down. Now, which pieces of this are going to shut down and where does the data live until next Thursday when we fire it up?
There is no data, it's all fresh data and coming back on next Thursday. You can shut off this entire
You
infrastructure.
have absolutely no storage that stays on from week to week.
It's a
Yeah.
great solution.
In this use case.
Now, in this particular use case, in this particular idea implementation, he doesn't need data, but you can keep it running 24/7.
This is about
It's gotta pay
tomorrow's
for it.
dates, not last week's dates.
Yeah. So hold on to some of those.
Securing the digits.
Yes, sir.
Whatever it is.
There's a question here.
So if
Yeah.
the API is not changed and you're making the same database calls, does that mean, is there a guarantee that the read sees all the writes or not? That's typically not the case, right?
Yeah, this is asynchronous, so there will be a replication lag.
Right, so normally that means that can break that database. If
Um,
you write the data, you read the data, you don't see it.
So in this asynchronous scenario, yes, but if you're reading it, this is the way you will scale your databases in general, right? This is a general database scaling best practice. What RDS allows you to do is all of this with one click.
And you can do things where a user's own updates always come from the master, but
Correct.
reading updates from other users come from the rep.
Well, so that requires application code change.
Yeah, there's
Oh,
no
yeah,
change.
Yes, that will
That's
require
what it
code
is.
change.
All of this requires you coding to
Right.
having a session factory for writes and
Session factory for a
reads.
right,
yeah.
correct. So it depends upon how you want to manage, but it will require minimal changes because you're not worrying about infrastructure and hardware anymore. You're working on the higher pieces. So now that he has gone into multiple questions.
Any hooks to know when the replication happens? What's the lag?
Replication lag is a metric that you can monitor from CloudWatch.
But you can't monitor your
Benchmark it,
application.
come on, Constantine.
It's on the millisecond speed. It's on the millisecond speed. I mean,
But not always, right? I mean, not always, right? I mean,
Oh, but
it
that's-
might be a lot
Yeah,
slower.
yeah, if it
Right,
depends
right.
if you're running in a separate availability zone, yes, it will have an application.
right, right.
Right.
But you can monitor that replication lag as well, from understanding how many you want, how whether it's working for your application or not.
That's a standard way database is.
Standard way in which how you scale your
Yeah.
databases in general. So now that there are several things that were cool about this particular application. And there were no past memories. You can be whatever happens in those 3 hours stays in that 3 hours, right? And you can be a doctor one day, and you can be a philosopher one day, and so forth. So you add several new features, and adding new features requires code changes and so forth. So he now comes to that 6th pattern, which is automating the complete in the cloud software development lifecycle. And this is very important because cloud really is enabling this automation to kick in, right? And so how does he do that? Some of these is he maintains these several dev, test, production scenarios. For dev, it is everything in one instance. For test and QA, it's 2-tiered with a small database. And you can instantiate the entire database with just one click again. So it creates a staging environment with production environment, and a production instance is actually a 2-tier multi-AZ high availability environment. So it always stays up for that 3-hour time frame or whatever. Right? So he does all of that using CloudFormation. CloudFormation allows him to specify the entire infrastructure stack in a script. So you can say, I want one load balancer, 2 database servers, read replicas in a multi-AC environment. In this one script, it will instantiate that entire thing. So there is this really cool way in which how you can increase your developer productivity as well as reduce your cost. So he adds new and new features because it's now continuous deployment, continuous integration. He can actually add much more features much more effectively. And now he gets tech crunched. He gets /started. Lots and lots of people are using his services now. Lots and lots of few of the customers. Few colleges picked up Ivy League and so forth. He's getting lots and lots of requests, and he can horizontally scale. He can horizontally scale his website. It has a better design on the database side as well. Static workloads are coming off from the static storage network, storage service, as well as the content is distributed via CDN. So far, so good, right? Question?
And to save things till next week, he could actually, some of that data could be out in some S3 storage, is that right? If there's something to retain from.
Yeah, he can retain, all the backups are
registrations or
happening in
something.
S3. So yeah, you can take restore a snapshot, point-in time snapshot. The beauty about EBS is that you can take point-in-time snapshots to S3 with a single API call. And each snapshot is incremental in nature. It will only store the deltas. So you don't really store the entire blob again. It only stores the changed bits. So it will save on your cost as well. So you're taking periodic snapshots every hour. You can restore that point-in-time snapshot in your database back.
Like, for example, some side database that merely had accounts or something, and not the information.
Of course, yeah, correct. So now that comes into my thought. Now he is getting famous day by day, and lots of customers are coming and accessing this service, and lots of people are getting their own dates. What about performance? Right? We worked about scalability, we worked about fault tolerance, we had a higher availability environment, and so forth. But what about performance? Everything is different, and you want to build that layer in there. And that comes to the seventh pattern with cache as much as possible. And so from a 2-tier kind of a design, he kind of goes into a 3-tier design. So in this scenario, he has his web servers and app server. He can do even further splitting, run web servers separately than application servers. They're Tomcats differently. They are auto scale. And he starts Amazon Elastic Cache modules, which are essentially cache nodes that you can spin up and do minimal code change from the memcache side. Your requests are directly hitting memcache servers. If there is a cache hit, it will directly serve back. If there is a cache miss, it will go back to the database and actually make and cache it in further subsequent requests. So caching has been best ways to increase performance of your application because it's not hitting and not doing that I/O in the database. Is that a good design?
My application thinks that as a SQL call. As a database call, or do I have to pull out the database calls and put in cache calls?
No, you have to do code changes on there to read memcache. Nodes are your SQL queries. Your queries will hit the MySQL only if there is no cache.
Or it's not memcache.
Your application actually.
Memcached. Elastic Cache is just Memcached nodes.
Yeah, but
It's not a JDC call.
the application code needs to go to the database and then pull stuff in the memcache.
Correct. Yeah. In this you have Memcached. You essentially do cache hit. You have your application will first see the cache. Node whether there is a cache. If it's not, it will make a.
Okay, so that
In this sense, this diagram is incorrect.
Yeah, your
Because
diagram
there is no
shows a
read-through
read-through
on a cache.
Memcached is not a
Should be
read-through
diamonds.
cache.
Yeah, so think of this as like a site scenario here, and then
Okay.
this is coming directly to the cache. But what I wanted to kind of
I
emphasize
got it.
is that caching will improve the performance, and here you're using Elastic Cache to kind of increase the performance, not having to manage that entire cache cluster.
In our use of S3, I didn't notice the ability to set the cache life of static objects.
For S3 objects?
Yes.
Okay, what was your question?
Is there an ability? to
You can set TTLs on each object, but currently by default it's 24 hours, I think.
Okay.
But you can set the threshold to set it to 1 hour.
I mean, the HTTP table, the HTTP cache header?
Yeah.
Yeah, you can take cache headers on each object.
Okay, cool. I didn't know.
CloudFront, if you're using CloudFront, then you might want to, that's a stack, this is edge caching. Are you using CloudFront or not?
We were using Jet.
Jet S3.
Yeah.
It's a library that
Right,
uses.
and I didn't see that in the APIs, but it may have been there.
Yeah, it's there, and you can change the cache header.
Just an architectural question. So given, I mean, I understand why Memcache exists, given that that's a product separate from MySQL database, but why did Amazon choose to reproduce that architecture? It seems like it would be much smarter to put that caching layer inside this abstract RDS, so that it would actually support, I mean, you would still think it was the database, which would really put into a cache layer, so then it could do graph application, I mean, it could be much smarter than.
Yeah, but we wanted to make sure that not all customers want caching, right? Not all
Sure,
customers.
but can that be a checkbox then? I turn on my cache.
Well, I think something the RDS is exposed as a MySQL instance, right?
Correct, yeah.
But it is my
No, but what he's
API,
saying that,
not necessarily MySQL instance. I mean, it's an API, right? It's a service. So why not make that service a lot smarter, where the caching is part of something? Maybe it's
yeah, he essentially wants an abstraction. Yeah, it's a different,
It couldn't have to be. I mean, it could be the same, right? I mean,
No, you have to have a query parser that you
Yes,
can.
but that's right. I mean, it's a
you can translate your cache to SQL.
That's the opportunity to solve that. So you can solve this better. I mean, this Memcache needle has always been this big hack, right? Because you have to understand when to validate the cache. Right?
I understand.
The database knows when to validate the cache. It's not maybe solved, but it seems like that's the best place to put it.
I stand trying to do that.
Is it
Oracle
too hard?
invested a
Okay.
lot of efforts.
Alright, so maybe just too hard report. So maybe
Yeah.
that's the way to answer that.
Yeah, some people want cache, some people don't want caching services. It might not be fitting for their architectures, right? They have to do an I/O call. They are doing more write-intensive work versus read-intensive work, and so forth. So Amazon's philosophy is to provide flexibility in everything, and there are multiple options to architect your application. Each of these is different ways in which you can architect. But I just have a context.
If you're concerned about code changes in your application to work with that, Hibernate actually has
Yeah.
functionality where it can deal with Memcache as a second level cache.
Yeah.
So it should be seamless if you're using Hibernate.
Correct. So now to our Hadoop questions that were there earlier, right? This is a site cloud tip. Now that he's generating lots of logs, he wants to be more data driven, he wants to understand what our customers are actually doing, and so forth. So what Hadoop is really doing is, tell Hadoop that I want to run, essentially one mapper and one reducer. You specify your mapper class and you specify your reducer class, and Hadoop or Elastic MapReduce will instantiate these name nodes and task nodes, which are essentially your mappers, in each of the different nodes specifically, so that you can run everything in parallel. And cloud really helps you to think in parallel as well, not just multi-threaded, but multi-node parallelism, right? So he takes all his logs. All his logs are essentially stored on S3 previously as well. Each of the task mapper will essentially take logs from S3, do the number crunching, create the reports, store back the output back into S3, and shut down the entire cluster. Hadoop has been one of the most popular ways in analyzing massive amounts of logs in a short period of time, because you can do expand and shrink of running clusters.
Are there, do you have pig connectors for S3?
Yeah, what connectors?
Pig,
yes.
connectors for S3?
For S3, I'll have to check.
Like, can I run a pig script?
You can
Just
run a
have
pig script on
S3
a,
script?
there is a Hive interface. You can run in a running cluster, and there is also a pig interface to it. So there is actually a video on there on YouTube which will be able to help you on. So let me skip this one for now. But essentially, what you saw was he's starting very small, now kind of growing his application slowly, understanding the requests of the customers. He's trying to build fault tolerance, elasticity, He's trying to build high availability, more performance. And now, what about security? That's also an important question, right? So that comes to our 8th pattern, is hardening security at every single stage is very important. Amazon EC2 provides you what, in the case of the cloud, it's very important to understand that cloud is a shared, security is a shared responsibility. And you have to understand what levels, who is responsible for what. And I like to call this now kind of in a way that anything below, from the concrete to the hypervisor, your virtualization layer, is Amazon's responsibility to make sure that it is secure, making sure that it is, you're having the right certifications, right security models, right standards in place, and anything above the hypervisor down up to the stack, your UI, is responsibility of the application developer. Making sure that your application is patched, or operating system is patched, making sure you're not doing SQL injection, preventing SQL injection or cross-site scripting. All those are applications developer responsibility. So Amazon has all these certifications for its infrastructure. If you're running, if you're running e-commerce application and you have credit card workloads, Amazon's infrastructure is PCI DSS level 1 compliant. So you can take advantage of some of those requests as well. But the beauty is that even if you don't have that credit card workload, you still get the same security without paying for any of the infrastructure and so forth. There are a variety of different service security features in place which will help you build more better secure infrastructures. So here you either use VPC, you have multi-factor authentication to access and log in, you do encryption, you have security groups, which I'll talk about in the next slide, and there is application security, which is a responsibility of the application developer. Now, if you think that you need more security, you can do encryption in transit, encryption at rest. You have the flexibility and the controls to use your existing systems in place. So you are rotating your keys, you're securing your own operating system, and so forth. And together, by maintaining this, you will build a highly secure environment for your application. Right? So a typical best practice for building highly secure application is to kind of isolate your security groups. Security groups are semi-stateful firewalls for your EC2 instance. It manages your ingress access, your ports, your protocols, your IP addresses, right? So here you say, all my web servers are actually going to have are going to have one security group. Their only port 80 and 443 is going to be open for that. All my app servers is just going to talk to my web servers. They're not. All other ports are going to be closed for that. All my databases is only going to talk to my app servers. Right? So you can build that security by isolating your security groups and have no access to all other EC2 instances. For example, you need port 22 open for your Tomcat instances. You can only have that particular port open. So by isolating your kind of firewall setting, you can create a better secure environment for your EC2 instance. So what he did was, he essentially just created these variety of different security groups. All this can be bootstrapped. All this can be automated into a script with CloudFormation as well. So you are baking in your security principles so you don't make errors when you actually launch your newer EC2 instances and so forth. And that's a benefit of the cloud as well. So now he's getting famous, right? He's having a secure design. He's having a highly fault-tolerant design. He's going global. He wants to think more better architectures, and he changes his name from Andy to Andy Zuckerberg, right? Just a joke, but essentially it is you're seeing lots of traffic, lots of colleges picked up his application. You're getting famous. It's a good problem to have, right? It's a success is a good thing. So now he wants to make sure that his application is even more highly available than before. Then he wants to make sure that application runs all the time. He wants to have more lines of availability for his scenarios and so forth. So he goes to the next level of creating high availability architectures. by adding more entire stack to another availability zone. Now that he has the same APIs, he has the same CloudFormation scripts, he has, he can quickly bring up the entire stack in another availability zone. He can have fault tolerance across availability zones. So if the entire availability zone dies, which is coming to your question, right, he can fail over to this another availability zone very quickly. So that way is building even further more higher available architecture by adding more and more EC2 instances when he needs it and so forth. Lots of our customers, especially Netflix and others, they are running 100% on AWS. And how they are actually creating high availability architectures is by splitting their traffic across multiple availability zones. Right? Instead of running 100% on one availability zone, they run 1/3 of the infrastructure in 3 availability zones. So if one availability zone dies or there is no connectivity, it can quickly scale up and add more resources to other availability zones and add more EC2 instances to it. So it can create more better architectures, more better designs by adding more redundancy into his architecture. So now that he is famous, he wants to go global. He wants to have this particular application in all parts of the world. Right? He wants to replicate this experience for every single city around the world. And then he also does very, very cool things here as well. So, but there is a problem also in here, right? And this is the coolness factor. There's a question? No? Okay. So he has his infrastructure running in US East. He has people accessing from a variety of different parts of the world. Speed of light problem. There is going to be geographic latency. There is going to be latency for customers who are accessing from that region. The solution is to run infrastructure in each part of the world so that your customers are essentially much more closer to your infrastructure and you have lesser latencies. You don't have transatlantic latencies and so forth, correct? So he builds, and he was smart, and he was really understanding the value proposition of the cloud, as well as Amazon provides this geographic diversity. You can create infrastructure in 5 different data centers using the same APIs. You have to move your resources, your Amazon machine images, and migrate and make sure they're available in each region. But he created something even cooler. He created what I call the follow the sun model. Right? So every 9 a.m. to 5 p.m. is actually when the Asia traffic is actually live. He is scaling his infrastructure during that time because it can actually have more infrastructure running during that time. And then as the night approaches, there are less users accessing that particular service. It shrinks back the servers from 5 to 2. Is this a cool design? Cool. Right, so he is essentially following the sun. He's using GeoIP directional DNS to actually route the right requests to the right servers, as well as he's for his in this particular scenario, that he's actually scaling on demand during that time. So it's it's essentially websites that sleep at night, as well as he's scaling that infrastructure horizontally as well. Question?
Can you talk a little bit more about how the GeoIP directional DNS works?
Yeah, this is a small experiment that I implemented. I used MaxMind open source GeoIP database on an EC2 instance, which is essentially a big IP address database. But there are lots of directional DNS and ultra DNS and other services provided by third party that you pay for like $500 a month. You can actually do lots of cool global server load balancing as well.
Tell me about that purple line at the bottom.
Yeah, that's a good question, and I know that question will come. In this particular scenario, in this particular use case, he doesn't really have any interaction. He doesn't like a person in Asia is not going to date a person in England or whatever, right? So in this scenario, what I have done is I've done a software-based data replicator. Essentially, every trigger will do a replication for in other regions as well. But there are different ways in which you can architect, and based on your application architecture as well as your use case, you can design this particular layer as well. And there are 3 different ways, and I knew that question was going to come up, so I had this slide. Right? So the first design, of course, is first design is that you have a software-based data replicator, an instance which is essentially looking at monitoring all the triggers that are happening. Any update, any insert will take that data and do update and insert.
So that's purple bar becomes 4 purple squares, 1 in each region, passing data to each other. Is that right?
Correct. Yeah.
The corrective data.
Yeah, but there are other architectures as well. Other things that some of our customers have built is is having all the writes happening to one region. There is going to be lots of geographic latency, yes. But in this scenario, at least he's just maintaining one master and then multiple slaves in each of these regions. Right? That's another architecture that will work with different types of use cases. Right? The third one is, of course, doing master-master application. I don't recommend this one. This has failed most of the time. But this works in scenarios where you want to take advantage of the existing MySQL features in place on an EC2 instance. So it depends. Like, this is not the architecture that will work for all use cases. It will work for certain types of use cases. It worked for Andy. It worked for other types of use cases as well.
Could you say what the difference between the multi-master and the first one you had was?
First one is a single master having writes.
No, I mean wasn't the one before, was that, is this a different solution or is this just a?
This is having an RDS slave. This is a different solution.
You're right. What is that? Yes, what is that? Why is that?
That's your software.
Yeah, why is that?
Yeah,
easier
that's
than-
your software.
So why is that
You have
better than
software-
MySQL built-in multi-master? What makes this easier?
So you are not relying
Synchronous writes.
synchronous, yeah.
Synchronous writes.
With multi-master, MySQL gets really confused if 2 things
Correct.
change the same tuple at the same time. It will blow. This is where you have something monitoring the triggers
Oh, I see.
and then
Right.
replicating,
You got it.
essentially log replication.
Correct. It's just essentially taking a trigger and then replicating that and doing another insert in another part of the world.
So each master is doing atomic transactions.
You can use your own versioning scheme. Sure.
Correct.
Last-
Yeah.
last
And it
row.
has an overhead,
You're trying
yes.
to resolve the conflicts.
Yeah.
But the thing is, it need not, if the database need not talk to each other, they don't have to talk to each other. They can continue to be in each of these regions as well. And you can replicate data across depending upon your architecture, depending upon your use case. You can have different types of database architecture designs. So the point was essentially doing follow the sun, which was clearly a good value proposition in the cloud. Right? Can you do that in an on-demand infrastructure, in an on-premise infrastructure? Can you shrink and grow your infrastructure based on your demand, based on your traffic patterns, based on your details, and so forth? So, another question.
Are you, the last company I worked for, we did cross-region application. Are you going to talk about that?
No, I'm not going to talk about that because you don't really need cross-region replication.
Well, there
You
was
will
that
need cross-region
small-
for disaster recovery
Yeah,
purposes.
there's that small East Coast problem.
Yeah, and I agree. For disaster recovery purposes, you might want to replicate your data and keep the data and actually do the whole thing. Move your Amazon machine images to EC2 to other parts of the region as well. There are tools, there are some services that are available. There are some, there's a tool that one of the solution architects actually built, which will migrate your Amazon machine image from one region to another region. So you have to keep that, use some of those tools, migrate and keep those Amazon machine images there.
We were running both regions live and doing something with load balancing between them.
You can use Ultra DNS, that's a global load balancing tool.
Just a.
How am I doing on time? Is that?
Well, 7 minutes. You almost
Okay.
done, or?
I'm almost done, sort of.
As an S3 infrastructure question, if I have not load balanced, but I've got a East Coast version of my app because I've got a customer's division over there, and the same customer has a division on the West Coast, and they're both writing data into, and it doesn't go away on Friday morning, but it has to stay around, so it's writing it to S3, I assume.
Yeah, but if you have your endpoint in US East and you're using US East as your data store, it will not automatically replicate. It will be your
Yeah,
responsibility
okay, so
to
there's
store.
yeah, there really are, it's two different sets of data. What would I do to bring that data together? I mean, when it's,
Together.
I mean, eventually, I need to make another set out of the merge, it's a MapReduce problem.
You mean just a rsync problem?
No, it's, they have their files that I'm.
You're partitioning the data is what it sounds like.
The
Two
data's already
sets of
partitioned because it's
separate
really
data.
geographically separate.
Yeah.
Now I have to bring it together
So you bring it together and you want to store it in a separate data, one single.
in a new place, yeah.
store? Yeah, you can essentially run, there are rsync and S3 sync utilities available, which will take your data and you use it in one location, let's say just EC2 instance, and pulls data from the different endpoints and does
and then I can-
duplication, deduplication.
And then I can do something in the
And
background.
then that's your data repository that you will be querying for the.
Or you could just create a facade that talks to both and treats them as one too. I mean, there are
Correct,
lots of
that's
ways to
another
do
way
that.
as well.
It's starting to get into architecture specific issues.
Yeah, it was just but you can think of it in this question as passive files, the results of.
Yeah, if there is a file in this location, the facade we're just talking about is just to have an EC2 instance which is saying, go query, is there a file with this particular file name in this area, what is the latest version, and get that file rather than actually downloading that entire file and keeping it on that EC2 instance. You just are doing a get call, a head call for your
Okay.
file name rather than actually downloading the entire.
It's a similar problem to log aggregation,
Yeah.
which
Yeah, in a sense.
there's a couple solutions to that.
So now Andy is getting more richer, more famous, more money, and more other areas. He can do much more effective things.
buy it.
In this. So that comes to my 10th pattern. And optimizing is one of the coolest benefit of the cloud. Now, you keep on optimizing your infrastructure, you keep on saving on your infrastructure costs, right? And you will see that getting reflected in as early as your next month's bill, because that doesn't happen in the general sense scenario. So here, what he does is kind of doing reserved instances philosophy or a purchase type. There are different ways in which you purchase an EC2 instance. One is on demand, which is just like our mentioned, which you pay 8.5 cents an hour for a small instance. You pay 3 cents an hour for a micro instance, right? And I told you there are different types of Amazon EC2 instances, correct? But if you go and purchase a reserved instance, you know your predicted, that your usage curve, and you say, I want 2 reserved instances. In this scenario, you pay upfront cost, one-time low fee for your reserved instance, but your 8.5 cents an hour reduces to 3 cents an hour. So your overall, for a 1-year term, you will save like 36%. You're going to run fully utilized Amazon EC2 instances for 24/7 for a 1-year period. Then reserved instances is going to be 36% less. You can purchase a reserved instance for 1-year term or a 3-year term. So this is a business model change. You can invest a little bit more and even further reduce a cost. It guarantees you capacity and other things as well.
A question I wanted to ask on the previous slide had to do with, following the sun. Can you follow the moon? Try and reduce your costs by having everything you run in the middle of
and
night
that's my next
instead.
experiment, actually. That's
I mean,
something that I'm working on.
Off hours time.
Yeah, exactly. You can do that too. Follow the moon is mainly driven by cost, right? And right now, there are no ways today to actually do more, get the cost, what's the current cost, but there are different
Your
ways
Wall
in which
Street
we have.
customers might like that.
Customers
So,
might like
so
that.
Amazon doesn't have a pricing at like midnight, between midnight and 6 o'clock pricing
Yeah,
type.
so something that I skipped earlier was, just like you have reserved instances and on-demand instances, you can now purchase spot instances, right? Spot instances are essentially bidding for unused EC2 capacity. So you say, I want an EC2 instance to start only if you match this particular price. Your price changes every hour, right? And it's a complete spot market also. We publish the entire market also on our EC2 instance dashboard. So you say that I want to instantiate all my servers only if it matches this particular price. So in these scenarios, lots of people currently today, like Vimeo, for example, is running spot instances for doing video transcoding for their free customers. for their free customers, they want to optimize on cost. So they want to get the lowest minimum possible. And if it's not available, it will fail over your on-demand instance. So they have the algorithm that will do all these cool things. And it's a case study up on there, which is really cool. Same way, you can bid for higher price as well and get more capacity that way too. So you can use EC2 instance, reserved instance, and spot instance in variety of different combinations to actually do much more cost optimization.
But there's no guarantees of throughput, right? So just getting,
No, it's not for live websites, Jason, it's for like late night data processing or something.
but the
Correct.
Or it's for free customers,
they don't care about.
Data, requires
Yeah.
data throughput.
Do you need
I have
3 hours of
CPU
MapReduce or
throughput
what?
guarantees, but no data
You
guarantees.
don't have any guarantees.
So let me come back.
Well, if I have 2 CPUs that are mine, then I can use.
They're not yours.
Okay, so
Yeah,
I have-
the downside of spot
So
instance.
following the cheapest machine doesn't necessarily even guarantee that I'm getting the most number of cycles or bytes.
That
per-
would-
Yeah, it
Yeah, that
depends
would be
upon
fine.
what type of EC2
Yeah,
instance you are spinning, what is your
Done by
request,
the end of the
what
week.
time of the day, and so forth.
Right, the Vimeo example is a good example. Free customers, they don't care, you know?
Yeah, they don't, it's
Upgrade to a
okay.
paid version if you want a better service, right?
Right, correct. So in the premium offering, what they offer, they have a direct mapping of how many customers are signed up. They have paid for it. They don't wait. They cannot wait. They don't have to wait for any of the video transcoding needs. So they purchase reserved instances, a direct mapping of number of customers to reserved instances because they already paid for it, right? So they use the reserved instances and spot instances together. And sometimes during a Saturday night, lots of people actually upload lots of video because they have free time. They actually use reserved instances and on-demand instances to actually go more above, to add them more, like to get more EC2 instances in this way. It's kind of using all it in good combination.
Isn't it true the reserved instance is still shared though, right? I mean, you're just guaranteed you will be able to get
So
it.
the downside-
Right.
so the
It's not-
downside
it's not
are-
more throughput. I mean, that's not, you're not getting, it's not like you've got that box. You've
You
got
get the
right to
EC2
box.
instance. You
But
get,
but that's shared still, I mean, so I still might get.
no. It's an EC2 instance.
Virtualized.
Yes.
It's
understand.
virtualized, yes.
Right, exactly. So it's no
Everything is a
difference.
virtualized
Right, so
instance.
it's no difference it's just a price.
Correct. The price, if your maximum bid price is below your spot price, it will take away the EC2 instances as well. So you need to architect your applications so that it can checkpoint and actually also resume from the last.
So you
from the-
may only get 1 hour,
You-
and then you might wake up 3 hours later and continue. Is that the
It depends what is your price, right? If your maximum bid price is 5 cents an hour and the spot price is around 3 cents an hour, your EC2 instance will continue to work. But think of this as a time insensitive tasks, right? Your log processing, your genome sequencing, or for your anything that is not require so much real-time aspects to it, you can say, I want to set a price tag on my workload. If it matches, then only do it. And if it is not matching, I'll wait for it and then start another one or increase my price as well.
But after some time, it might turn it off. Is that what you're just
Yeah,
telling
so
us?
you
Yeah, it's a
It's a
spot
checkpoint.
price, right? It's like a spot market.
It's not
And it
guaranteed
checked
money.
every hour?
Every hour.
So you
correct.
might get only 1 hour at a time, spread out during the whole week.
No, it depends. If you bid higher, your price.
I
will
know
be
if you bid higher. What if I bid low?
When you checkpoint,
Yes, every hour.
checkpoint is
Half
every
a
hour.
cent an hour is my price.
Of course, if I get the highest price, I'll be done when it finishes. But-
Yeah, so you always bid a little bit lower than your on-demand rate, and you will make sure that you're always above the curve if you're highly sensitive, right? Where you want your data to be there. But the beauty about it is that you can run elastic MapReduce clusters with spot instances. So look at the combination. What it does is essentially you learn all your log processing, everything. If your price matches, you set your persistent request for this time, for this price, for this availability zone, for this instance type, and it will provision your infrastructure when it actually.
So Andy's example is if he wants to process his log before the next Wednesday night or the next Thursday.
Correct, right.
He bids low and he's got all week to get it.
All week to get it done and learn from his requests and from the processing and so forth.
Closer he gets
So
to
from the analytics report, how do you
He
want to
better
actually
start
get
clicking if it's still at Wednesday and he hasn't done.
Question, sir.
So about that, this is probably asking for too much. A pig script can fire off dozens of map reduces.
Yes.
Is it sensitive to the stages of pig? I mean, that would be a great feature. 'Cause if
Sensitive to the.
Right, if it knows it's in stage 5 of a pig map reduce, and all the temporary files are already there, so they can always be restarted.
Mhm.
It would be awesome if your spot instances could work that way.
So spot instances directly go to.
In other words, you run a pig script, it may do 3 map reduces.
Right.
Between every map reduce, it's storing files on disk.
Mhm.
And those files on disk are your checkpoint. You can restart the second phase if the spot goes away after the first phase.
Mhm.
And instead of starting all the way back to the beginning again.
You're right,
Some of
right.
these map reduces can run for hours.
Correct. Yeah, it's a good point.
It'd be a really cool feature. I'm certain you don't have it.
Yeah. It's a good feature, and we want to hear this feedback. This is great feedback. I am not sure, but let me get back to you on that particular aspect. And if you can send me an email, I will run it to the product manager very quickly.
When I'm trying to set a bid price where I want it to run, is there any kind of a feedback that's going to tell me the probability of having that run, say, during the next 24 hours?
There is a spot market that we publish all the rates for the last 40 or 45 days. So you can see how much actually it will be. And if you go to the dashboard, you will be able to see the complete graph of what's the price fluctuation of each instance, region, and so forth.
Okay.
Sounds like your mileage.
Question?
How do you get notified when you're going to be shut down?
How do you get notified? You get notified through your SNS service. So you
Okay.
get either an email that your service is going to be. This is a feature request actually that was there earlier.
And in what kind of time frame do you have? You have some warning, like you have like.
No,
2
what we
seconds or
recommend
10
is
minutes?
we recommend is that you build in the checkpointing into your application architecture, so
Sure.
you can resume your state whenever later on.
Sure.
So that is our request, and there are different best practices in the spot instance guide, but we don't. It might get terminated. There is no advance notice.
So you have to treat it as a failure, essentially.
You treat it as a failure, exactly.
It will kill your process.
Yeah, you're dead.
Yeah, so essentially you're sort of designing for failure for all your processes in this.
Designing for failure anyway, they'll just bring some for you.
Yes.
Does RDS sit on top of EPS or is RDS completely independent?
RDS sits on the top of EC2 and EBS, but it does all these automatic aspects, right? All this automation, all the script management, it automatically does RAID as well, RAID 0, so it has 3 or more copies, simultaneously striped across multiple ones. You get more throughput instead of running just in MySQL on EC2, which you can do as well.
Right, you do the same thing.
Same thing on MySQL. Yes, sir.
Yeah, my question is related to SLA and high availability. Like, let's say if you are building and managing the applications for enterprise customers, one of the cost factors like high availability, 3 nines, 4 nines.
Yeah.
And does Amazon support different SLA high availability? Or it
So
just
this is
one?
the whole thing which I talked about, right? How do you build high availability
Let's
architecture?
say we'll still talk about the rainy day and probably.
Yeah, so Amazon offers EC2 and S3, 3 nines of availability which is availability SLAs, so availability of their APIs as well. But your instances and everything else is still, you can build these redundancy architectures to ensure you get more high availability on your architecture. This is how large systems are actually being built as well, right? You build redundant frameworks and things fail all the time. Hardware will fail, disasters will occur, outages will occur. But if you design your applications which are spanning across multiple availability zones, your applications will be much more fault tolerant and have high availability. And that's a design principle that I think you should embed in your design right from the start. So what we just saw was how Andy actually went through a one single EC2 instance to a highly scalable, highly distributed, highly available, and globally deployed application using all the different services that cloud really enables today. This was not possible 2 years ago, 3 years ago when cloud was not there. Now it's so easy to get started. It's so easy to get build better architectures without having to worry about hardware and infrastructure. So anybody still care about what happened to Andy?
Did you find his name?
So Andy did following his cloudmate, his soulmate. They are madly in love with each other, and he lives happily ever after as well. But everybody knows. What is that?
He's pulled up a new instance.
But everybody knows the first love is still the cloud. So anyway, thank you very much. If you like this presentation, you will like other white papers that I have written. You can find the slides here. You can send me an email if you have any questions as well. There are several white papers that I have written which design for failure and all the architecting for the cloud, best practices and principles, and kind of way in which you should architect applications that work at scale. So thank you very, very much for
And I know we're a little over time here, so if you guys got questions, meet in the lobby for beers. Hopefully you'll join us.
Yeah, I'll stay for some time.
Okay,
Thank
great.
you very much for asking questions. It was good interactive discussion. I hope it was informative.
Excellent. See you all next month.
Yeah, feel free to add me on LinkedIn or.
Excuse me. Sorry.